Hello students, this is the last part of this chapter, and in this we are going to basically focus on the extraction, metallurgy and refining of aluminium and iron. These two are actually very important metal for commercial purpose and household purpose also. So we will start with mining ores, then we'll move to extraction and finally refining of aluminium and iron. So let's start. Extraction of aluminium and iron. So let's start with extraction of aluminium, and as we know, the first step of extraction of any metal is the mining of ores. So and from ore we do our metallurgical processes to obtain our metal. So the first thing is to identify and obtain the ores, and the main ores of aluminium are bauxite, cryolite, feldspar, mica and other, but the most important one is bauxite. This is highly used for extraction of aluminium. It is a chief ore of aluminium. Okay. Then once we have identified bauxite as an ore, the next step is purification of bauxite actually to eliminate the impurities. Okay. And for this, what is done, that bauxite is reacted with sodium carbonate and calcium carbonate at 1100 degrees Celsius, which results in formation of these three compounds. And these are the chemical reactions involved. And the first one is that aluminium carbon, that is oxide. Bauxite reacts with sodium bicarbonate to get sodium aluminium oxide. Okay, and these are the reactions of impurities which are removed. Then this sodium aluminium oxide is reacted with carbon dioxide at 50 to 60 degrees Celsius to make in the presence of water, that means aqueous solution of this sodium aluminium oxide. We pass carbon dioxide into that and we get aluminium hydroxide, and this aluminium hydroxide is then heated to get back our ore bauxite. So this is the method known as Hall's method used for purification of bauxite. Next, there is another method which is known as SPECS process. For this, what is done, that bauxite containing a high percentage of silica can be purified by this method. In this process, finally powdered bauxite is mixed with coke and the mixture is heated to 1800 degrees Celsius in the presence of nitrogen, and then aluminium nitride (Lin) thus obtained is reacted with hot and dilute NaOH to produce sodium aluminium oxide, and excess of Lin is hydrolyzed and aluminium hydroxide is formed, and then aluminium hydroxide is heated to get back our bauxite. It is similar type of reaction which we studied in previous process also. So these are the reactions basically, and the chief reaction of bauxite is that the bauxite reacts with coke and nitrogen to form Aln and carbon dioxide. This Aln, which was, and rest of are the reactions of impurities, and this Aln is dissolved in water to form aluminium hydroxide, and this aluminium hydroxide is heated to get our bauxite back, which is pure. This was impure, this is pure now. So this was another process for purification of bauxite. Now there is Hall-Heroult process, which is used for extraction of aluminium from bauxite, and this is electrolytic refining method in which the electrolysis of bauxite is done. Actually the electrolysis of molten bauxite is done, and into that some cryolite is added, and cryolite is added actually to decrease the melting point of bauxite ore. So in this we have copper clams, we have carbon as anode, and we have carbon as cathode also. So both anode and cathode are made up of carbon, and into this what happens, that cryolite is added to alumina, that means ore mixture, to lower down the melting point and to increase the conductivity of electrolyte. Okay, so there is a question that why cryolite is added into the mixture, into the alumina, that means reactant mixture, or we can say the ore mixture. Then the answer is, it is added in order to lower the melting point of it, okay, and also increase the conductivity. So overall reaction is actually like into the cell is like Al2O3 reacts with carbon to form, it is reduced by carbon to form aluminium and carbon dioxide. And actually there is a need to change the anode. We have anode. What is anode? These are carbon clamps, and we need to replace these after a regular interval of time. Why? Because these are used up in the process. The oxygen liberated at anode reacts with the carbon of anode to produce carbon monoxide or carbon dioxide. So with the passage of time, the carbon present at anode is actually utilized, and that is why we need to replace the anode, carbon anode, after regular interval of time. Now let's have a look at the metallurgy of iron, and we start with the ores of iron, and the most famous and the most general ore of iron is magnetite. Also we use hematite, red hematite, then brown hematite, and there are number of other, but the most important are hematite and magnetite ores for iron. Okay, now let's have a look at, okay, then what we do concentration of ore and roasting and calcination if needed. Then we move to extraction of iron in blast furnace. Special type of furnace is used. This is basically pyrometallurgy. We apply heat, very high heat, to obtain the metal, and it comes under pyrometallurgy. So we need a furnace which is called blast furnace, and into this blast furnace hot air is this is the structure actually of blast furnace, and hot air is blown from bottom of the furnace, and coke is burned to rise the temperature up to 2200 Kelvin in the lower portion. The temperature is lower in the upper part, thus the lower portion where the reduction of oxide takes place. Okay, so what is done basically, this is the structure of our blast furnace. We pass hot air to the lower portion to burn the coke present in it, if coke is there, and the limestone, the ore plus limestone plus some coke also is added into the furnace from top. Okay, so there is a temperature, there is order of temperature. The temperature is very high at the bottom, and then it keeps on decreasing to 2000 Kelvin, then 1500, then 1000, then 100 Kelvin. So there is a actually regular pattern of temperature: high temperature zone, then low temperature, then middle temperature zone. So there are different type of reaction which take place in different zones of the blast furnace. The reaction which taking place in the lower temperature range, that means 500 to 800 Kelvin, that means up to this area, in the uppermost area, are that first of all we have added the ore Fe2O3 from upside, that reacts with carbon monoxide which is formed by burning of ore in the bottom, and it forms two molecule of Fe3O4 plus carbon dioxide. There is another type of reaction, that the same Fe2O3 reacts with with carbon monoxide to form FeO and carbon dioxide. Okay, there is another reaction which takes place in this region, is that this Fe3O4 which was formed here reacts with carbon monoxide again to form FeO and CO2. So overall reaction is that Fe2O3 reacts with carbon monoxide to form FeO, iron oxide, and these reactions take place in low temperature range, upper part of the blast furnace. Okay, so first of all, iron Fe2O3 reacts with carbon monoxide to form Fe3O4, then this Fe3O4 further reacts with carbon monoxide to form FeO, and there is another chances that this Fe3O2 directly reacts with carbon monoxide to form FeO. In either way, we are getting iron oxide. Okay, now there are some reactions which take place in higher temperature range, that means into this area, this portion, and what is that? That carbon in this area, coke which was added, reacts with carbon dioxide to form carbon monoxide, which is used for the chemical reaction in this area, and the iron oxide which was formed into this area and moved to this area reacts with carbon monoxide to form iron, which is known as pig iron, actually a raw iron, and carbon dioxide, and this iron accumulates at the bottom and is taken away from this side. Okay, now there were some impurities also along with the ore. The silicate impurity of the ore is removed as slag by calcium oxide, which is performed by decomposition of limestone. And what are the chemical reaction are that calcium carbonate, limestone, which was added along with the ore, react with calcium oxide, it decomposes into calcium oxide and carbon dioxide, and this calcium oxide react with the silica impurity to form calcium silicate. So we can say that this was flux which was added to remove the impurity in the form of calcium sludge. Okay, so this is how the process takes place in blast furnace, and this is the summarized way, in a diagrammatic way, what are the chemical reactions which are taking place. We add iron, coke, and limestone from top of the furnace. Then then what are the chemical reactions in this area? Carbon is converted into carbon dioxide. In this area, carbon dioxide is converted into carbon monoxide. Then this carbon monoxide at this place reacts with iron ore to form iron and carbon dioxide into this area. Then this iron which was formed at this point moves down and reaches into this area, collected here, and then it is removed. There is another chemical reaction which is taking between calcium oxide, which was formed at this point by the decomposition of calcium carbonate. Okay, calcium carbonate decomposes here to give calcium oxide, and this calcium oxide reacts with the impurity calcium SiO2 silica to form calcium silicate sludge, which is accumulated at this time and removed. Okay, now alloy steel. Okay, what is steel basically? Steel is an alloy of iron which is formed in order to increase the strength of iron and to improve the properties also. And there are different type of steels. The first is nickel steel, which contains 2 to 5% nickel, which is along with iron. It is very hard, tough, and resistant to corrosion. That's why it is known as stainless steel also, and it is used for making gears, etc. Then there is a chromium steel, which is alloy of nickel, chromium, and carbon. This is also resistant to corrosion, stainless steel, and it is used for making household materials. Then there is a manganese steel, which contains 9 to 14% manganese along with iron and carbon, and it is very hard and it is resistant to wear, and it is used for making helmets. In the similar way, there is another Inwave, which is another type of steel, and it is formed by 30 to 36% nickel, 0.3% carbon, and obviously along with iron. And its coefficient of expansion is very low, and that is why it is used for measuring instruments. And there are two another type of steels also in a similar way. So here we studied about metallurgy of aluminium, metallurgy of iron, and also alloys of iron, steels. Students, in case you have any doubt in this topic, you can post that question in our discussion board. For that, all you need to do is to go to the home page of Ask IITians. There you will find an option of discussion board. You have to click there. Then in the right side, you will find a portion of Ask Experts. In that, just select the category in which you want to post your question. Let's say it's physical chemistry. Then post your question here, and then if you want to attach any image, use this option to attach the image, and finally post it by clicking on Get Answer, and you will be answered within 24 to 48 hours by our experts. So now we are aware of different methods of metallurgy used for extraction of aluminium and iron. Okay, so in this chapter we basically started with the first step, that means mining or obtaining the ore from earth crust. Then we moved to the concentration, that means how to remove the rocky impurity from these ores. And then we moved to extraction of metals, that means once we have removed the impurity, what are the methods by which now we can extract our metal. And then once we have extracted the metal, we need to refine it. So in next part we move to the methods which are used for refining of the metals which has been obtained from the ore. And in the final one we discussed about metallurgy of aluminium and iron. With this the chapter finishes. I hope things were clear to you. This is an important chapter. First of all, it is very easy. It may not have very much weightage for IIT-JEE exam, but whatever weightage it has, it is a bonus for you because it is a very easy chapter. So go through this chapter number of times and clear all the concepts. For more videos on physics, chemistry, biology and mathematics, stay tuned with Ask IITians. Thank you.